This video is concerned with simultaneous equations. Now, what we're going to deal with here is a set of equations, and we're going to try and find solution to the equations that satisfy all of the requirements of the individual equations. And you'll see what I mean by that as we work our way through it. But there are no high-powered here expressions. Everything is linear. So we're dealing here with simultaneous linear equations. I suppose if we wanted to be precise, we should insert the word linear. But simultaneous equations is what the literature calls it. That's what it's known as in schools and universities and colleges. So we'll call it simultaneous equations. But it is technically linear. There's no squared or cubic terms or high-powered exponents in the equations. So we have a single equation and one variable. When we have that, we can solve it. So we have a single equation, one variable, we can solve it. So there are several videos that I've put up on this where there's just simply something like 2x equals 6 or whatever. So we have one equation. There's no complications with the x term. It's not squared or cubed or anything. It's just 2x equals 6. And we can solve it. So we have one variable and one equation. If we have two variables, we need two equations. And equations can't be just multiples of themselves. They have to be unique equations. They have to be different equations. We'll see what I mean in a few moments. So if we have two variables, we need two equations. If we have three variables, we need three equations, and so on. When we have two variables, we need two equations, and we can solve these simultaneously, and that's what we're doing in this video. So let's take something like 4x equals 20. Now we have a single equation, one variable. Now we can solve that. 4x equals 20. We can just divide the left hand side by 4, divide the right hand side by 4. We have x equals 5. So both sides balance. What we did to the left hand side, we did the same to the right hand side, and it balances. So we have one equation, 4x equals 20, and we have a solution. We have one variable, one equation, and we have a solution. If we have two variables and one equation, we can't solve it. If we have y equals 3x plus 6, in this case, y depends on x. So if x equals 3, then y would equal to 3 times 3 plus 6. 3 times 3, 3 3s are 9, 9 and 6, 15. So y would equal 15. We put the numbers in the brackets. This means we multiply them together. So it's just a way of writing. If I put the cursor on the screen here, I could have put a little x in between, but I just don't want to introduce another letter. It starts to get confusing. So it's acceptable when you put numbers or expressions in brackets and another bracket just touching it. The two brackets are multiplied together. So 3 3s, 9, 9 and 6, 15. In fact, in this case, we could take any value for x. We took x equals 3. We could have x equals 10. 3 tens, 30 plus 6, 36. So y equals 36. Y is the dependent variable. Y depends on x. X does not depend on y. It's the other way around. X is independent. So with two variables and one equation, the value of y depends on the value of x. And we can give x any value. So we're not really solving it here. If we have two variables and two equations, then we will have a solution. We can solve it. The one earlier we couldn't solve because the value of y depended on whatever value we gave to x. But to get a solution, we need two equations. For example, y equals 2x minus 1 and y equals 3x minus 4. So we've got two equations now. Now we can solve these. We can find unique values for x and y. Make sure that the equations are distinct. Make sure the equations are different. They're not just like, take the first one, y equals 2x minus 1, and the second equation is 2y equals 4x minus 2, because that's the same equation, just written differently. We just multiplied the second one by 2. So it's not, these equations, I should say, are different. They're not just a multiple of some number. We're not just multiplying this by a number, because if we do, it's essentially the same equation. We can always divide by that number, and we'll get back to this one. This one is different, so we can do this. Note here, since the two y's are the same, y equals y, it must be that 2x minus 1 is equal to 3x minus 4. So 2x minus 1 equals 3x minus 4. Now we can start solving this. So we can say add 1 here. So we have minus 1 plus 1. Of course, we have to add 1 over here. That means we can get rid of the 1's here. Minus 1 plus 1, that goes, leaving us 2x. And over here we have minus 4 plus 1, which is minus 3. So we have 2x on the left hand side and 3x minus 3 on the right hand side. Now take the 3x from the from the right hand side. There it is. Take it away there. We must also take it from the left hand side. So we have 2x minus 3. So we've taken away the minus 3 from the left hand side and from the right hand side. Again, keeping the equation, keeping it balanced. But now you see here we've got 3x minus 3. Those can drop out, leaving us minus 3. And we have 2x minus 3x, which is minus x. So we have minus x equals minus 3. Multiply each side by minus 1. If you do that, you get minus x times minus 1, which is x, minus 3 times minus 1, which is 3. So we have x equals 3. So we've solved these two equations. We found the value of x. Now we could substitute back in here to find the value of y if we wanted to. We could say x equals 3, so 2x equals 6, 6 minus 1 is 5, so y equals 5. So substitute that back in there, like I've just said. Now we've got y equals 2 times 3 minus 1, which is 6 minus 1, which is 5. So all we've done is substituted the 3 back into the equation. We've solved the equations. We've got x equals 3, but x equals 3. You can put it up in the top one if you want, equation 1. So you have 3 2's are 6, 6 minus 1 is 5. Put it in the bottom one. 3 3 is 9, 9 minus 4 is 5. So it works. It must work for both of them. So therefore the solution to that is y equals 5. It's also you can solve the other equation in the same way. Substitute x equals 3 into that equation there, y equals 3x plus 4, and work your way through it. We've got x equals 3, so 3 3 is 9, 9 minus 4, which is equal to 5, like I said before. So the solution is to y equals 3x minus 4 is y equals 5, and there it is. Now we could solve this graphically. It's easier probably to solve it algebraically, but we can solve it graphically if we want. The solution is found by graphing each equation and finding their intersection. At the point where both lines cross, the values of x and y may be read off, and these are the simultaneous solutions to the equations. We can do the same for two equations as previously, so we can again substitute in as we did before. So if we start with y equals 2x minus 1 and y equals 3x minus 4 for equation 2, and just write in 2x, and 2x minus 1 is down here. So we've got the value of x here, and we've got the value of y over here. And that's for equation 1. So equation 1 is this one. We have some values for x, and we have the y values associated. So we got those. Now we can plot those, and we can use a spreadsheet to do it. You can use Google Sheets or Microsoft Excel or whatever spreadsheet you like using. We use Google Sheets, but this is when you graph it, that's what you find. You find that relationship there. Turn to equation 2. We get this relationship here. It's done exactly the same. We put in values for x, and we have 3x minus 4, and you write down the column there, and then you graph it with that. And if you insert both of them together on the spreadsheet, you'll find the cross. And all you need to do now is read off the values where they intersect. There's a 3, and there's that 6, or is it? Or 5 over there, sorry. So you just read off the values. Just make it precise and read off the values. When x equals 3, both equations 1 and 2 are equal to 5. And it can be seen from the graph. So if you just put a ruler there and take it across, it just goes in there. So it's 5, 3. Oops, sorry. Okay. When x equals 3, both equations 1 and 2 are equal to 5. And this may be seen from the graph. Note, however, if we have more equations than we have variables, we can't solve the values for variables. So we need, if we have 2 variables, 2 equations. If we have 3 variables, 3 equations. 1 variable, 1 equation. And that's the rule to remember. We must have the same number of equations as variables if we are to solve for the values of the variables. So solve 2y equals 3x and 3y plus is equal to 2x plus 10. So we've got 2 equations here. So we start with 2y equals 3. We'll deal with the first equation. Now divide by 2, so we got 2y over 2 equals 3x over 2. That leaves y in its own, so it's 3 over 2x. And what we've got now is so we got that relationship there, so we'll just keep that. Now we move on to the next one, which is 3y equals 2x plus 10. This is equation 2. And now if you divide by 3, so you'll get 3y divided by 3, which is just y, 2x divided by 3, and 10 divided by 3. So we've got this relationship here. So we've got y equals 2x over 3 plus 10 over 3, and y is equal to 3x over 2. So we have 3x over 2 there from here, and we have this lot here, here. Now we've now got 1 variable and 1 equation. We can solve that. We've moved from 2 equations and 2 variables down to 1 equation, so we can solve this. That's where we got the figures from, as I pointed out to you earlier. And here we are again. This is the way we've got it. Now we're going to just work our way through here. So if we multiply by 2, we'd have the 2 drops out here. So 3x times 2 over 2 is just 3x. 2x times 2 is 4x. And 10 times 2 is 20. So multiplying all the way across by 2 leaves us 3x on its own, but we've got these numbers up here. We can get rid of the 3 by multiplying everything by 3 now. So if we multiply by 3, we got 3 3's 9x. Well, that 3 just cancels, and that 3 just cancels. So it's 4x plus 20. 9x equals 4x plus 20. Take away the 4x from the right hand side. You must take it away from the left. Take it away from the right hand side. There it is, 9x minus 4, 4x minus 4. So we've taken this away. We must take it away from the left hand side as well, which is here. And plus 20, of course. We'll keep that. So now we've got 9 minus 4, which is 5. And that x and that x just drop out because they're equal to 0. 4x minus 4x is nothing. So it's equal to 20. And x equals 4. So we've solved for that. So equations 1 and 2, right? Well, with equations 1 and 2, we have those are the equations, and we can put x in now. So we have x equals 4. So that's 3 times 4. The bracket, remember, time is the same as multiply. And over here we have 2x, so it's 2 times 4 plus 10 is equal to 3y. So we've got 2y is equal to 12, and we've got 3y equals 8 plus 10 is 18. Divide by 2 and divide this one by 3. So y is equal to 6 and y is equal to 6. So we've solved it. That's the point. We've worked out the unique values. Now if you go back to the original question, that was not obvious, but by what we call elimination, we have eliminated one of the equations, subsumed it into the other equation, and then solved it. Take a different example. 2y is equal to 6x plus 16. That's equation 1. And equation 2 is 3y is equal to 2x plus 17. Now we want to find the values of x and y. So that's our original equation. So let's just keep it there. Now 2y equals 6x plus 16. Divide by 2 to get rid of the 2y, get it down to y. So you have to divide everything by 2. Divide that by 2, 6x by 2, and 16 by 2. So we've actually got y is equal to 3x plus 8. So equation 1 comes down to this one. So if we just move across here, we've the same thing. 2y equals 6x plus 16 is the same as y equals 3x plus 8. Now equation 2, we got 3y equals 2x plus 17. Divide by 3, we get y on its own. But you have to divide 2x by 3 and 17 by 3. So that's not as nice as the first one. We've got fractions here, but we won't be put off by fractions. We have equations 1 and 2 in terms of y. That's the point. So if we set them equal, both are equal to y, you see. So now we can say that 3x plus 8 is equal to 2x over 3 plus 17 over 3. So we can say that because we have y's are the same. And if we take away 8 from here, we have 3x on its own is equal to all of this here, which doesn't look very very easy or very nice. If we multiply this by 3, we will have to multiply the 2x over 3 by 3 and the 17 over 3 by 3 and the minus 8 by 3. But at least it's going to get rid of this denominator here, the 3's, the denominators. So that doesn't look too bad. So if we write it back up here again, it's the same expression. Just go back, you'll make a note of that one, and we've just written it up here. Now that means that we got 3x times 3, which is 9x, and the 3 and the 3 cancel out here, so leaving us 2x. The 3 and the 3 cancel out here, leaving us 17. And here we've got 8 minus 3, which is minus 24. And when we do the arithmetic here, we take the 2x over here, so we've got 7x equals minus 7. In other words, x equals minus 1. So now we've got our y values. We've got our x value, but we can now write the y's here because we know what x is. So we can take one of the y's, say y equals 2x divided by 3. Take this one here. 3y equals 2x plus 17. Here it is here. We divide by 3, so we have 2x over 3, 17 over 3. So that's the one there. We know what x is now. We just calculate it. It's minus 1. So instead of having x, put in minus 1. So that becomes minus 2 over 3 plus 17 over 3, which is equal to 15 over 3, which is equal to 5. So y equals 5. So we've got, when we go back to our original equations, we've got y equals 3x plus 8, x equals minus 1, and we've got y equals 5. And that's how we solve simultaneous equations. We've worked out the values of x and y, which causes the equations to intersect. It solves the equations. The equations, each equation gives us a different perspective on the answer. And when you set the equations to equal each other, we work out the answer, which in this case was x minus 1, y equals 5. And that solves those pair of equations. It doesn't look like it's going to solve it if you look at the equations to look a lot more complex. But in fact, the solution is quite straightforward. And all we did was we started off by taking 3x plus 8 and equal 2x over 3 plus 17 over 3. We did that. We set that equal to that because y is the same. So the two of these are the same. So just set equal. Now you've got one equation. You've got 3x plus 8 equals 2x over 3 plus 17 over 3. You've got one equation, one variable, x. So you can solve for x. Once you've solved for x, put that solution into one of the equations. You can put it into both if you wish. You still get the same answer. But put it in. So x becomes minus 1. Do the calculation and you find y equals 5. And that's the solution to a simultaneous equation. And all we're doing is writing it out. So we have y's. The y's are equal to something over here. Y equals y. So that equals that. Now we've got one equation and one variable, x. Now we can solve for x. Just manipulate that to get x on its own, and you've solved the simultaneous equation. And that's all we'll do with this one. So let's leave it at that and say thank you for watching.